Yes, the mic's on. Alright, so the area of the Alamo, we start with this rectangular piece. How do you find area of a rectangle? Base times height, so 12 times 8 is? Okay, everyone should be able to get that part. Thank you. Then the slightly more difficult part is this half circle. So since we have no formula for area of a half circle, we need to find the area of a full circle. So that formula is A is pi r squared. We fill in our numbers here, so pi, 3.14. The radius is not 6, it's half of that, which is 3. We always do the exponent first, so 3 squared is 9. 3 times 3. Then we have 3.14 times 9, which hopefully we worked out, which is 28.26. No, 28? 26. Is it 26? Okay. It's 28.26. That would be the area of what? Of the full circle, but we only want half of that, so we need to do 28.26 divided by 2, so we get 1, 4, 1, 3. So the area of that circle is 14.13. Oops. So we add that to 96, and you get 110.13. Wonderful. So everybody got that right? Thumbs up, thumbs down? These should all be thumbs up. There's no thumb sideways. It was yes or no. If you got it, you got it. If you didn't.
Wait, what did the 8th graders think about the red guy? They probably got scared. Mr. Willis, if you get an odd number, is it okay if you round?
No rounding. Unless it tells you to round, don't round. Alright, the house is a little bit simpler just because there's some decimals, but they're not as bad. So we're finding the area of this without the door. Oops. So we can start with this rectangle bottom here. So that'd be 12 times 10, which is 120. But included in that is the door, which we don't want. So what is the area of this door? 12. So we have to subtract one from the other. So the area of the bottom part, not including the door, would be 108. Because 120 minus 12 is 108. Okay? So that's part of our answer. We also need the roof, though. And what shape is the roof? Trapezoid. It's a trapezoid, so the formula for that, it's not base times height. It's kind of like that, except when we add 2 bases and divide by 2, we're finding the average of the bases times the height. So we can say one of our bases, the short side is 5. What about this side down here? Why do we know that's 10?
Because the bottom part is 10.
So since this was a rectangle, the top and bottom have to be the same. The height is 6, because how are base and height always related? They always make a right angle. Okay? So then we just do the math here. So 5 plus 10. So we have half of 15 times 6. So we could do 15 times 6, or we could say, what's half of 6? 3. And then 3 times 15. So what is the area of our roof? 45. So then how could we find the total area? we just add them up. So we say, what's 108 plus 45? It's 153. There you go. So let's see, thumbs up, thumbs down if you got that one right. A little bit better.
But I got the first one right.
Oh, well, that's a 50% if you got 1 out of 2. Yeah.
I got them both wrong. I got half. I got them right.
All right, let's start. If you have your test corrections, pass those up.
Can I do the tutoring tomorrow?
Yeah, I was gonna go for it.
Can I do it?
The only homework I gave you last night. We are going to look at number 6. Yes. So number 6, it says to draw a triangle, and it gave you original points to plot. I think one of them was 1, 1, and what was it? 4, -2, and -2, -2, correct? And this, which one was A? And then B?
Or -2.
Okay. So here's our original shape. So you should have been able to plot that without much trouble. The second thing it told you to do was to transform it with a scale factor of 3/2. Correct? So all we had to do, just like we did yesterday, when we said it had a scale factor of 2, what did we do with our x and y coordinates? What operation did we do? We multiplied all the numbers by 2. When the scale factor is 1/2, what did we do with all of our numbers? Well, we divided them, but that's the same as multiplying by 1/2. So you always just multiply the numbers by the scale factor. So in this case, if point A is at point -2, -2, if the scale factor is 3/2, we're just going to multiply both those numbers by 3/2. So we're going to say, what's -2 times 3/2? So we can multiply straight across. So 2 times 3, 6, negative. 2 times 1. So we have negative 6 over 2. Does that simplify to something? Yes. What's it? 3 over 1 or just negative 3. So we can say A prime, our new A, is going to be at negative 3. What do you think our Y value would be? Negative 3, because it's the same number. If we multiply it by 3/2, we're still going to get negative 3. So we can plot that point. It would be right here. Okay? We do the same thing for B. So point B was at 4, negative 2. Well, we should already know, what is the y coordinate going to be? What's negative 2 times 3/2? What did we just work out? Negative 3. We just did that. Correct? So then that leaves us with 4. Can we do 4 times 3/2? Yes. There's no negatives. So we multiply straight across, so 4 times 3?
12.
Hopefully you're writing this down if you didn't the first time. If you don't have anything down for number 6 and all that space to the left, you should be writing this out. Or to the right. So 12 over what? 2, because 1 times 2 is 2. What does 12 over 2 simplify to? 6 over 1 or just 6. So B prime is going to be at 6, negative 3. So we go 6, down 3. Yes, Jeremiah. Okay, and then A, or not A, C. C is at 1, 1. So what's going to happen when we multiply 3/2 times 1? What's any number times 1? Itself. So what's 3/2 times 1? 3/2. So C prime would just be 3/2, 3/2. Or 1.5, 1.5. So we go to the right 1.5, we go up 1.5, and we end up right in the middle of that square. C prime. So we can connect these. Do we end up with the same triangle?
No. Somewhat.
Yes. My drawings aren't the best, but yes. It's just what? Bigger or smaller? It's just bigger. Okay, the second part of that question says, what is the ratio of the areas? So there's 2 ways we could do this. We could actually find the area of both shapes, or we could remember what we talked about yesterday. How does the area change? It gets bigger by how much? By just the scale factor? It's always the scale factor times itself. So we say the new area is the original times the scale factor squared. We talk about area. So if our scale factor was what? 3/2. So our area would change by a rate of 3/2 squared. So we'd have to multiply 3/2 times itself. So take a second, think about what that would be. Don't shout it out because you're probably going to get it wrong. I know that sounds mean, but it's just the truth. We had kids all day yesterday trying to tell me that 1 times 1 was 2. They were everybody. So what do we get?
3.
What's 3 times 3?
9.
What's 2 times 2?
4.
Oh, I thought you were just simplifying.
It's not 1.5.
I know, I thought you were
9/4 would become what? 2 and 1/4. or 2.25. So if it asks you how does area change, you have to look at, you take the scale factor, you times it by itself. Okay? So are there any other questions on that one? Okay. So pass those up.
What about the perimeter? How does that differ?
How does the perimeter change?
Scale factor.
It's just times the scale factor. Because the exponent that you put here is always the same as however many dimensions you're dealing with. So area is in 2 dimensions, so we square it. Perimeter is in 1 dimension, so it's just to the first power. And then volume, when we get to it, is scale factor cubed. I already did. This homework that we just went over? Oh, this one? Yes. Just like I did with the one yesterday where we yelled at Jeremiah.
We're on YouTube, Jeremiah. Yeah.
Alright, before we start with this page, I want to give one problem just so we can see how easy it is to make a mistake on this and get our answer wrong. So if you want to write this down, you can find somewhere on that paper where there's some extra space. So if we have a rectangle with an area of 40, okay? Your notebook side. And let's say we want to change it by a scale factor of 1/2. So is that going to be an enlargement or reduction? Reduction. This is going to get smaller. My question to you, and don't shout it out, I just want you to put what you think, what would be the new area. So don't shout it out. Just put down whatever answer you think it might be, either in your notebook or somewhere on the top of that paper. What you think the new area will be. Scale factor. Not San Francisco. That's something else. So raise your hand if you think you got it. Okay. 20. 20. 20. 20. 20. 20. So we're all in agreement here. Anyone want to give a different answer? Preferably a correct answer.
It's wrong?
80.
Okay.
40.
So
10.
there's 2 ways you can work this out. There's the old way, which the teacher who trained me showed me, which I never really liked, but I guess it helps some people who try to say it's 20, is if you have this rectangle, you think what sides could we put in that would make the area be 40? What could the length and width be?
10.
We could say 4 and 10, right? You could also say 8 and 5, 20 and 2, all good. If we take half the lengths of those sides, So what would this be here?
10.
So the area of this is not 20, it's 10. And we talked about this yesterday. We said if the question asks you to find the scale factor, how it affects area, if you just multiply it by the scale factor, you'll get it wrong every single time. And that's what just happened. Okay? Because we give you the area, we give you a scale factor, say I'm just going to divide it by 2, I'm done. That's not how it works. What did we say? We're talking about area is the original times what? The scale factor what? Times itself, or the scale factor squared. So if we take the original area of 40, and the scale factor is 1/2 times itself, what's 1/2 squared? You know, we did this exact same thing yesterday, right? I mean, you gave me the same answer yesterday. 1 times 1, still 1. 2 times 2, 4. So 1/2 squared is 1/4, not 1. So the new area is 40 times 1/4, or 40 divided by 4, which is 10. So what you need to remember is if it tells you to find area and you're dealing with scale factor, you don't just divide or multiply by that. You've got to square it first. Okay? If you square it, you get the answer right. If you don't, you get the answer wrong. There's no maybes. Sometimes it works, sometimes it doesn't. It's every time. Okay? I don't want that to happen. So the very first thing we're going to do is let's start off nice and easy. And we're actually going to add a couple lines in here. We're going to say, yes. And so we can find the perimeter of our triangle too. So we're going to find the area and perimeter. We're not going to do anything with scale factor just yet. So we're just going to look at, and don't actually write it on the lines just yet, just on the shapes above it. What is the perimeter of this square?
4. Wait, no, 2, 4, 8.
So this original perimeter is 8. And we're going to use these because if you look at all 3 rows there, the shapes are always the same, correct? So we're just going to work this out one time. So the perimeter is 8. What's the area of that square? 4. Okay, how about this triangle? The perimeter would be 9. And the area is 3. And our last rectangle has a perimeter of 16. Remember, how do we find perimeter? We just add up all the sides. And the area of that is 12. Okay? And what we're going to do, we're going to start with a scale factor of 2. And we're going to see how does that change the perimeter and area. So if you look at that square, if you change it by a scale factor of 2, what would happen to the perimeter? It would go up by how much? It would double. So we could either just double it and say 8 times 2 is 16, or we could actually draw the shape, and if we doubled the lengths of the sides, it'd be what? 4. And we get a perimeter of 16. Okay? How about the area of our new shape? And how does that relate to the area of the original?
It would just be times
Maybe times 4. Where do you think times 4 came from?
Because it was 4.
Just talking about scale factor. How can you get a 4 from that?
Scale factors 2, so you do times 2.
Because we said when we're talking about area, we take the scale factor squared. Okay, how about the perimeter of our triangle? That again would double. And if you don't believe it, you can draw it out. If you double all the lengths, you'd get 6 and 6 and another 6 on the third side, which is a total of 18. If you want to. Okay, how about the area? What would happen to that? What would we multiply our area by? And don't say 2.
6 times 4 divided by half.
Times the scale factor squared. So what are we going to multiply it by? 4. So we take the original area times 4, we get 12. What's the scale factor?
2.
What's 2 squared?
4.
The same reason why we multiplied it by 4 for the area of our square. 3. We took our original area times 4. Okay? If you don't believe it, you could work it out. So 1/2 of 4 times 6 is... So if you don't believe the shortcut, you can always fill in the numbers and work it out. Okay, how about the perimeter of our third rectangle? Every time, what have we done with the perimeter? We've just what? Doubled it. Since our scale factor is 2, we multiply the perimeter by 2. So this will be 32. What have we done with our area every time? We multiplied it by the scale factor squared. We multiplied it by 4, so our new area would be 48. Again, if you don't believe it, if this is 12 and 4, 12 times 4 is indeed 48. Okay, not so bad. A little bit scary. All right, so if we go to the next one, it changes by just a little bit. Now we're going to look at the scale factor when it's 3. So take a minute, try to fill in the answers. Yes, try. So think about how the perimeter and area are changed by the scale factor. No, there's a new row for you. Look further down the paper.
No, I'm saying, should we
Right. All these shapes are the same, so these perimeter and areas of the originals don't change. It's just going to be the new perimeter and area is going to change.
wait, so we still do the 2 square, which is 4?
It wouldn't be 2 squared, though. Now it would be 3 squared. So how much does our perimeter should change by?
9 times 6.
Whoa, no, the perimeter. The perimeter we're just going to multiply. The perimeter is just going to be times 3. And the area is going to be times 3 squared, which is 9. Don't giggle, you said it too.
I thought 32 is 6.
3 squared. 3 times 3. It's not 6. Yes, Robbie. All 9 of them. Yes. Yes. You should be able to do 3 and 4 now. 4 is the same thing. Just with bigger numbers. Come on, we need to be writing down more than that. Hey, didn't you see that movie, Rise of the Guardians?
No.
Santa's
Yeah.
totally real.
Was those owls?
That was a
He
it,
seems Russian.
it was a documentary. Okay. So, okay, back to this. So the perimeter, we take the original perimeter multiplied by 3, so what's 8 times 3? So this new perimeter would be 24. On the triangle, the original perimeter was 9, so what do we do with 9? Times 3, we get 27. The original perimeter on this one was 16. If we times that by 3, we get... Yes, times 3, because the scale factor is 3. All right, then we do the area. So our original area was 4. What are we going to multiply that by to get the new area? Times 9. So we say 4 times 9 is? 36. Okay. We take the area of the triangle. The original was 3. What are we going to multiply that by?
9.
By 9. That's going to give us?
47.
And we get one of those special numbers for perimeter and area are the same thing. Isn't that neat? All right, and the last one, the original area was 12. So what are we going to multiply 12 by? And that's going to give us 108. Okay? So now we're going to do this one last time. But now we're going to use the scale factor of 4. So if we have a scale factor of 4, the originals still aren't going to change, correct? Yes. But now what are we going to multiply the perimeter by to get the new perimeter? Times 4. To find the area would be times 4 squared. Or, okay. So let's get this done pretty quickly. Alright, so what would our perimeter of our tiny square be? 8 times 4 is 32. How about the perimeter of our triangle? 9 times 4 is 36. And then our perimeter, 16 times 4 is?
64.
There you go. Okay? Then our area, finish. So our area times 16, so what's 16 times 4? Is 64. Over here, 16 times 3. And then 16 times 12. Oh my gosh. Okay? So the big thing you need to remember is that very last question on there. On the front side, don't turn over just yet. It says, how did changing the dimensions by a scale factor affect the area? It got bigger by how much? Not just by a scale factor, but by the scale factor squared. That's what you got to remember. It's that one last word at the end that's the difference between getting it right and getting it wrong. It's the scale factor squared. Because area, we talk about square units. You mean as far as the perimeter? We didn't ignore the 2. The original area would have been 2 times 3, which is 6, and then half of that is 3. Yes, for tonight, you're going to try the questions on the back. Yes, of course it's for a grade. Yes.